Hi, hello everyone. All my legends, kaise hai sab? And how was the day? It is almost the end of the day, na? So I have to ask you, how was the day for everyone? I know that nowadays many of you are going to schools, got some good memories, had an amazing day, I suppose, right? So yes, this is Ameer, your physics educator at Unacademy. And if you all can see me and hear me, jaldi se jaldi, fatafat, give me an amazing thumbs up in the chat box. Go for it quickly, everyone. And do let me know that I'm super audible and visible to everyone. And I also know that some of you do love me a lot, Anna. So those people who love physics and Ameer Bhaiya so much, you can give me a heart in the chat box. Hi Taiba, that's a very good name. Sanjana, Jatin, Arkit Hacker, Arkit Hacker. ठीक है? Avocado, hi, hello everyone. कैसे? Where is the Josh? Let me know that you all are on high energy and you all are ready to learn the very last session of this particular chapter of ray optics, where we will be discussing about the microscope and the telescope. Tell me, are you all ready? Let me see some fire in the chat box and do let me know that, sir, we are super ready. We all are ready to learn this topic of ray optics with you. Sanjana, very good. Hi, Miara. Very good, very good. Now I can see a lot much of fire in this chat box. Very good. Sugamana, Miara. Thank you so much. Whoever is seeing me for the very first time, a brief introduction about myself you can see on the screen, right? More than 3.5 years I have in the field of teaching JEE, NEET and board student. I'm a beta graduate from an IT Calicut in mechanical engineering. I taught and mentored many students from across the country and this is all about me. ठीक है. Now, if we look into the schedule of Legends batch today, which is on 30th of September, we'll be having the very last class of ray optics, which is optical instrument. And the next class is on 3rd of October, matlab Sunday at 3 p.m. We are going to be having the complete revision of the chapter of alternating current. You know how important this particular chapter is, right? Alternating current, and we are very fastly approaching towards amazing educators with whom you would love to start learning, right? And with whom you are already learning. And if you don't want to miss any live classes from them, what do you have to do? Go to the Telegram channel. The link is given right here, because from this Telegram channel you will get updates and notification of all the classes happening from all the teachers in this YouTube channel. ठीक है? You know that for this term 1 examination, we'll be having the new examination pattern, which means with multiple choice question and assertion recent type question. So if you want to ace in this new exam pattern, what do you have to do? Yes, we have to do lot much of practice, and you know that how amazing and how caring Unacademy is. That's why we have started the Emerge program, where we'll be having, or you will be having, the live mock test every week. Think of, you keep on writing the mock test every week till you reach the exam. How amazing you are going to be, how amazing your performance is going to be. It's going to be super amazing, right? Super great it's going to be. So don't wait, now itself come and enroll for this Emerge program. And if you can get an amazing mark, where you can be, you'll be there in all the social media handles and YouTube channels. आप लोग बहुत famous हो जाएगा सच्ची में. Okay. And these are the dates given. Okay. Oh, okay, I forgot to change the date. I'll give you the new dates. Okay, fine. Then in the Unacademy subscription, why it is so much important? Now listen to me, give me 2 minutes, or listen to me 2 minutes why Unacademy subscription is too much important, and then we'll start with the very last class of ray optics. You know that nowadays everything is available for free in YouTube, right? But in the Unacademy subscription platform, we all educators will be teaching you with a proper schedule, targeting all the examinations such as board examination, JEE examination and NEET examination. And whenever we teach you any topic, we'll make sure that all the topics are in proper order and you can keep track of all the topic that is being covered in the classroom. So what happens at the end? Yes, the process of learning will become super simple for you. You can concentrate more. You can spend more amount of time on all these studies and grab more amount of information. Then you can ace in all the examination you're gonna write, and you can end up in the colleges whichever you are dreaming about. One reason. Top educators of the country are already there who are having a great and immense experience in this teaching field. They will be very well knowing how the exam pattern is going to be. What are the kind of questions you can expect for this examination? They'll be telling you, isn't it? And if you can follow them in the right way, Don't you think that you can get a very good mark for all the examination you appear and get into the colleges you are dreaming about? Yes, it is possible. Study materials will be given to you, live test and practice test will make you super confident and will bring out the best in every one of you. And for all these, if you're going for a 12-month subscription, it will cost you 1,250 rupees. And do you have to pay that much money? नहीं बिल्कुल नहीं, क्योंकि अमीर सर है ना. So this is the code. Use this code of AMB10 and get 10% of discount. Okay, don't forget the code is AMB10. Those who want extra features, okay, you are like, okay, we understood all the features of Plus subscription, but we want more features. If you want more features, it is better for every one of you to go for Iconic subscription, because here you will be given a personal mentor, someone to help you with your academic activities throughout 24/7. Let's say he'll be there to help you with the schedule, how to study, what should be a strategy for studies. For everything, this person will be there. Live doubt solving classes will be there. Weekly reports will also be given to you. For all these amazing features of Iconic subscription, for 12 months it will cost you 2,333 per month. Sir, discount code de de. That's what you're telling, right? So use this code AMB10 and get 10% out discount. ठीक है? Okay, बढ़िया. And let me tell you, there are two different reasons for me to tell you that this is the right time to take the subscription. Why? First thing is, an offer is going on till 4th of October, where if you go for 12 months, extra 4 months will be given to you, right? Along with the 10% of discount if you use my code of AMB10. And the second reason is, if you start learning now, you can complete your entire syllabus for, let's say, term 1 examination, or let's say for the JEE or NEET examination or your board examination, and you can get a very good mark in all these. So if you start now, this is not still late, you can start now and you can get a very good mark for all the upcoming examinations, right? Thank you. And yes, now it's time for our studies. Bol de, everyone, are you all ready? Sophia, Sanjana, Vita, tell me you are ready first, and also tell me that, sir, we are ready with full of energy, and I should also see that energy in the chat box. Jaldi. I'm doing so good, Sophia. Thank you so much for asking. Yo, Miara, let's crack it. Yes, I can see the energy from Miara. Hari Om, Hari Om. Are you ready? कोई बात नहीं पालक, please do watch the replay. ठीक है? Okay, do watch the replay. Sankamitra, Palak, Miara. So I hope everyone is with full of energy, right? So yes, let's get started with the very last session of this particular chapter of ray optics. So do you remember in the last class what all were the topics we were discussing? The main topics, or the topic with which we have ended the session, was regarding microscope. And I told you two kinds of microscope exist, right? A simple microscope and a compound microscope, right? And which was a microscope we were dealing it in yesterday's class? Tell me, which was the microscope? Yes, we were talking about the simple microscope. है या नहीं? बोल दे. हाँ sir, बिल्कुल. हम तो आपका साथ ही पढ़ाया. And what is actually a simple microscope? Yes, a simple convex lens itself is called as a simple microscope. Where did we keep the object? We have to keep the object between optic center and focus, right? And if you are getting an image at least distance of distinction, which means at D, what was the formula for magnification? 1 plus D by focal length of this. Okay, this was the first case where the image is formed at least distance of distinction. Sabko yaad hai? I'm just revising the topics we have covered. Then convex lens, image formed where? I formed at infinity. For image formation at infinity, where should you be keeping the object? At the focus, right? In this case, we have found out the magnification formula. It is D by F. Yes or no? हाँ या नहीं? बोल दे. हाँ sir, बिल्कुल. It was still here we have completed. But you have to know that in simple microscope, that convex lens which a palm reader used to see your hand, isn't it a very simple microscope? Which means, isn't the magnification of that बहुत small? Let me ask you, with this simple microscope, is it possible to watch amoeba or such kind of microorganism? Is it possible? No, because the magnification that can be produced by the simple microscope is very limited. In this cases, what will you do? If you want to observe that chotu microorganisms, we'll be using a compound microscope which will be offering you a huge magnification compared to the simple microscope. You all have seen that compound microscope. Yes, that microscope which you see in your labs. याद है? I'll show you the picture. This one. This same one is called as a compound microscope which you use in your labs to see microorganisms. Why we use compound microscope? Yes, to produce very large magnifications so that we can find chotu images, right? Shall we learn about compound microscope? Hannah, tell me, this compound microscope consists of how many lenses? How many lenses are there for this compound microscope? This one. This lens through which you will be looking. The first lens, which we call it by the name of eyepiece. Then we have one more lens. This one. The lens which is close to the object. And this lens is called as objective lens. So a combination of two convex lens is simply our compound micros. In simple, one lens was there. In compound, two lens was there. Shall we understand in deep about the compound microscope and its working? आ जाइए मेरे साथ, everyone. Okay. Now listen to me very carefully about the image formation in this compound microscope and how much is the magnification produced. ठीक है? How many lenses are there? Just now we have discussed. In a compound microscope, we have two lenses. Shall I draw? Yes. Sir, draw कर दीजिए आप. So हम draw कर रहे हैं. So we have one of the lens, which is eyepiece, and the one close to the object is where? Objective lens. Let me draw the principal axis. This is the focal length. Okay, this is the focal length of the objective. Okay, and let's say this is the focal length of the eyepiece. So here you will be keeping the object. सबको पता है ना? So let me keep the object. हमारा object का है, ये है हमारा object. So I'm keeping an object just beyond the focal length of the objective lens. I know that many of you will be asking, sir, why I have to keep the object beyond the focal length? Because in the simple microscope we were keeping in between focal length and the objective. I'll explain you. In the meantime, you also think why I have kept the object here. Okay, let's find out the image formation, right? We'll have a parallel light ray, okay, and it will be passing through the focus of the objective, as you can see, right? And another light ray, let me take, passing through the optic center, will be passing without any deviation. Can you see an image formation here? Right? So what is this actually? This is the image of the objective lens. So we have got a real image of the object kept here. Now tell me, if I was keeping the object between the optic center and focal length of the objective, which means if I was keeping the object here, what kind of image will I be getting? I'll be getting a virtual image on the same side here. If I get an image here, will that be any useful to the second lens? No. You will understand why I said that. देख ले. This is the object for what? This is the image for what? The objective lens. And the light rays from this image is actually passing through where? Passing through our next lens, which is our eyepiece. These light rays are coming from where? From the image of the objective. Now tell me, what this image will be acting as to the eyepiece? The image of the objective will be acting as what to the eyepiece? Everyone, who is going to tell me? The image of the objective lens will be acting as what for eyepiece? जल्दी 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 जल्दी. Anyone? किसी को पता है? Nobody knows. अरे, whenever a lens receives the light rays from any of the thing, it will be considering that as its object, है ना? So from where the eyepiece is receiving the light rays? From the image of the objective. So this will be acting as what? हाँ बोल दो ना जरा. हाँ, this will be acting as what? The object for eyepiece. It will be acting as UE. Understood? Okay. So this light ray will be passing through eyepiece ऐसे and it will be undergoing the deviation. And you can see that it is diverging here, and if you try to find out the image formation, you have to extrapolate, and if you extrapolate, you can see that they will be meeting here where an image is formed. Where? At least distance of distinguishing. And this is how the image formation happens where? In a compound microscope. समझ में आ गया? सबको समझ में आ गया? अच्छे से समझ में आ गया? हाँ? Okay. Now this is our initial object and this is our final image. We know that each of these are convex lens and each one will be producing its own magnification M1 and M2. So if this is producing a magnification of M1 and this is producing a magnification of M2, what will be the total magnification? M1 and M2. We have learned this previous classes. Yes or no? Magnification of first, magnification of the second, product is a total magnification. Tell me, what is the magnification of the very first lens, which is the objective? The object length is U0, right? And the image length is equal to V0. Formula for magnification of a convex lens, everyone knows. V0 by U0. कोई गड़बड़ है क्या? कोई गड़बड़ नहीं. Everyone knows. ठीक है. Look into the second one. Second one, isn't it acting like a simple convex lens or a simple microscope where you have an object here, right? And a final image is formed at least distance of distinguishing. है या नहीं? अरे बोल दे, you don't remember कल का class हमारा convex lens, right? Where you will be keeping an object here and an image is formed on the same side at least distance of distinguishing. इसका magnification 1 plus d by focal length. Isn't the eyepiece also acting in the same way? You have an object between focal length and objective, isn't it? And an image is formed at least distance of distinguishing. So इसका magnification हो जाएगा 1 plus d by focal length of the eyepiece. So now we got the net equation for the magnification of a compound microscope where the image is formed where? Image at least distance of distinguishing. समझ में आ गया? आ गया तो आ गया. सबको समझ में आ गया? अच्छे से समझ में आ गया? बता दे. Very simple it is. It's not a big deal at all. है ना? Yes, very good Miara. It is option D. Very good. बढ़िया बात है. बढ़िया बात. Okay. So understood the equation for magnification, the image formation happening in the compound microscope. आ गया तो आ गया. सबको समझ में आ गया. बिल्कुल बिल्कुल बढ़िया. Okay. Now देख ले. I hope you do remember with the microscope you used to adjust the length, right? Okay, you used to adjust the length of the microscope. So can you tell me how will you find out the length of the microscope, which is the distance between this objective lens and the eyepiece? देख ले. Starting from objective till here it is how much? V0, and the remaining is how much? UE. V0 means the distance to the image from the objective plus UE is the distance to the object from the eyepiece. So the length of a compound microscope where the image is formed at least distance of distinguishing is V0 plus UE. Everyone please do write it jaldi se. Take a screenshot or मार्क इट अच्छे से, कर दिया तो बता दे। हो गया? हो गया? जतिन, म्यारा, सोफिया, एना, ऋषभ, हैकर, यश. Okay, done. So shall we proceed? Okay. Now we have seen in the case of a compound microscope what is a magnification and what is the length of it when image is formed at least distance of distinction. Tell me what will be the next case we are going to do. Obviously सबको पता है ना? The next case we are going to do is the image formation where at infinity. No, I think I don't need to explain you much because you already know the concepts, right? We'll be having an objective and we'll be having an eyepiece, right? Yes, so we have an objective and we have an eyepiece, and let me draw the principal axis. वो भी हो गया. This is the focal length of objective and this is the focal length of the eyepiece. Okay, I'm keeping an object here. The reason why I keep the object beyond the focal length is so that I can have a real image on the right hand side of it, right? Okay, so how will the light ray form? A parallel light ray will be passing through the focus, and a light ray passing through the optic center will be passing without any deviation, and you can see that it meets here, right? If I use another color, which color? Green. So you can see an image is formed for the objective lens here, right? Okay, and the light rays will continue to move like this from the image of the objective and will now passes through the eyepiece. What happens? It will be undergoing the refraction, and you can see that in this case as the image of the objective lens is formed at the focal length of the eyepiece. How will the final light rays will be? Yes, the final light rays will be parallel to each other. It will be parallel to each other. So do you think that it will be meeting at any point? No. So where do you have the image? Yes. So we have the image at infinity. है या नहीं? And this will be acting as the image of the objective lens will be acting as what? The eyepiece is receiving the light rays from the image of the objective. So as this eyepiece is receiving the light rays from the image of the objective lens, it will be acting as what? Simple. It will be acting as the object for eyepiece. Any doubt in this? No. Understood this entire concept? Tell me what will be the magnification here? Magnification of the first into magnification of the second. Any doubt? No. What is a magnification in the first case? If this is the distance to the object and this is the distance to the image, the normal formula for magnification is V0 by U0 multiplied by magnification of eyepiece. Just compare this to a simple microscope where you have an object at its focal length and the image is formed at infinity. What was the formula for magnification there? We have learnt D by its focal length. Here we are considering the focal length of eyepiece. So the net magnification in this case is equal to V0 by U0 D by Fe. Look how simple. Who can tell me the length of the microscope in this case? Tell me, what is the length of the microscope in this case? I'm not going to tell you. I'll be looking just into the chat box. I want you to tell me what is the length of the microscope, the distance between the objective and the eyepiece. Who can tell me? किसको मुझे बोल सकता है? I'm doing so good, Cristiano, but I'll be more good if you can give me the answer. Jaldi se. Anna, it is V0 plus UE. Tell me what will be the UE value here. Tell me. You gave me the first part of the answer. V0 plus UE. Very good. Till then it is correct. What is UE here? The distance of the object from the eyepiece. Any idea? What is the answer? Nobody knows. Arey, itna simple hai. You do have the entire figure here. I'll tell you, arey, itna simple tha. Idhar tak, till here, it is V0 plus. This is where the image of the objective lens is formed. This is also the distance of the object from the eyepiece. This is UE. But we know that as a final image is formed at infinity, this object for the eyepiece will be at a distance of where? At the focal length of the eyepiece. That is the reason why the final image is formed at infinity. Hai na? So UE, the distance of the object from the eyepiece, has to be equal to its focal length because the final image is formed at infinity. So this is focal length of eyepiece. Bas, ho gaya. Only this much to learn from where? From the part of microscope. Jaldi se jaldi, please do mark it and mark everything in the chat, which means in your notebook. Priyu, Sanchana, Manisha, understood Anna, very good. Jatin, okay. कोई डाउट है तो पूछ ले मेरा बच्चा लोग, आपका अमीर भैया से पूछ ले, कोई डाउट है तो वी गोना स्टार्ट डूइंग द प्रॉब्लम्स. We are gonna start doing the problems. Screenshot ले लिया, ठीक है, बढ़िया. Okay, it shouldn't be like you'll be having so much of screenshot in your phone and without even looking at it. Okay, so look into the screenshot and do learn. Okay, so question. Okay, very good. It's a nice question. Before Ameer sir give me the answer, which means before I give the answer, let me see how many of you can give the answer here. Shall we? If eyepiece lens of a compound microscope is moved a little away from the objective lens without changing positions of object and objective lens. समझ में आ गया? You have the objective lens here. I'll tell you. We'll draw the figure. We have the objective lens here. We have the eyepiece. Okay. You know that if this is the focal length of the eyepiece, where the image has to be formed, where the image of the objective lens has to be formed, somewhere between optic center and focal length here, right? This should be the distance of the image from the objective, which will be acting as what? The objective for the eyepiece, the object for the eyepiece, है ना? हाँ, और क्या sir? बिल्कुल. Question is, if you are moving this eyepiece instead of keeping it here, what I'm going to do is, I'm taking this eyepiece and let me say that I'm keeping the eyepiece here. If the eyepiece is moved, its focal length will also move, right? So let's say this is the new focal length of the eyepiece. Okay, so here it became the new focal length. Where is the object for the eyepiece is now? Isn't this the object for the eyepiece? Yes or no? Yes or no? Yes. And if this is the object for the eyepiece, where is it now? Isn't it beyond the focal length of the eyepiece? देख सकते हैं आप लोगों को? ये है हमारा object of the eyepiece. This is the new focal length of the eyepiece. Isn't the object of the eyepiece beyond the focal length? If the object is kept beyond the focal length of a convex lens, what kind of an image will be formed? Yes, we will be having a real image and it will be inverted to the object. The object is this and this is going to be the final image formed. है ना? So if you move the eyepiece, what kind of an image you will be getting? You will be getting a real image, isn't it? Yes, we are going to get. And erect with respect to the object. देख ले, this was our first object, है ना? And look at the very final image. Aren't they erect? Aren't they pointed along the same direction. Yes. So which option? Option B. Final image will be real and erect with respect to the initial object. Bas? Simple. Very good, Miara. Amazing, amazing. Very good. Then, who understood? Before me you did, Sophia. बढ़िया बात है. Understood everyone? सबको समझ में आ गया? कोई गड़बड़ भी नहीं है. ठीक है. तो अगले क्वेश्चन कर ले. Okay, this is a question from the part of refraction from a plane surface. Let me see how many of you do remember this. Okay, the refraction from a plane surface. Okay, I'll just remind you the reason for finding the swimming pool a bit hollow, or the reason for the bottom of the pool to get lifted up. Remember that simple topic I have taught you. Use that concept and do this. I'll also do along with you. Let's see who's going to do first. A microscope is focused on an ink mark on top of a table. If we place a glass slab of 3 cm thick on it, how should the microscope be moved to focus the ink spot again? Shall we explain this? Dekh le. This is the side view of this particular our table, and we have our ink spot here. So by using the microscope, okay, हमारा microscope है. So with this microscope, entire thing will be focused and we'll be getting the final image. But to this particular setup, what is being done is we are keeping a slab on top of it. You know that whenever you keep a slab on top of it, the object will be raised up, which we call it as the apparent depth. Hey ya nahi? How many of you do remember? So you will find the object here at its apparent depth. So how will you find out this apparent depth? D apparent is equal to actual depth divided by its refractive index. याद है ना? हाँ. Actual depth कितना है? What is the actual depth? How much is it? 3 centimeters. Divided by, what is the refractive index? 1.5. 3 by 1.5 is 2. Which means you will be seeing the ink spot at a 2 centimeter. Actually, how much it was? At 3 centimeter. So tell me, by what length it has raised up? This is 2, this is 3. So how much is this? 1 centimeter. You will see that whenever you keep a glass slab on this ink mark, the ink mark will be lifted up by 1 centimeter. If the ink mark is lifted up by 1 centimeter, how much distance you have to move up the microscope so that the final image will be focused again? Huh? How much? The same 1 centimeter. Upwards or downward? Upward, because the object is getting lifted upwards. So the microscope also has to be moved accordingly by moving upwards by 1 centimeter. Bas, chotu sa question. है ना? Anybody gave the answer? कोई ने दे दिया क्या? Very good, Sudeep. Amazing. Seems like many of you have forgot this concept. I told you, whenever you are going to write JEE or NEET, or even let's say this year board exam, you'll be having multiple choice question. Multiple choice question will be application level question. Without knowing these kind of concepts and without knowing how to solve interconnected questions, थोड़ा tough लगेगा. So please do learn all the concept. ठीक है? Myara did before me. Very good. Then Sanjana Priyu, hacker. Hi hacker. Any doubts? और कोई भी नहीं doubt है? Okay, we'll do this very last question from this microscope and then we'll start with the telescope. शुरू करें? Very good Shivaji. Shivaji Chaudhary 1 centimeter. ठीक है, देख ले. Next question, everyone. Okay, very last question it is from the part of microscope, then we'll start with telescope. In a compound microscope, the focal length of objective lens is 1.2 centimeter. What is the focal length of objective? We can write here. Focal length of objective is 1.2 centimeter. Okay. And focal length of eyepiece 3 centimeters. Okay. When an object is kept at 1.25 centimeter in front of the objective. So what is given? Object distance from the objective lens is 1.25. Plus or minus, we have to measure it towards left, so it is minus. I am writing it directly. Final image is formed at infinity, which means V of eyepiece is formed at infinity. Final image of eyepiece, V of eyepiece. Magnifying power of the compound microscope should be. First, let us write the formula of magnification when the image is formed at infinity. Everyone, what's the formula for magnification? Yes, huh? V naught. Zor se bata. By U naught. I hope you all are telling inside your mind. Then, is it 1 plus d by fe or d by fe? It is simply d by fe. Right? Okay. What all you know? D you know. Focal length of eyepiece you know. U naught also you know. But V naught ka value we don't know. How will you find V naught? Anybody? Who can tell me how will we find V naught? Who can tell me how will we find V naught? Let's see. That brilliant minds. It's a very simple question. Hello Yuvraj. Jaldi bata de. How can I find out the V naught value? Nobody. Nobody can tell me. Itna simple question, no other teacher can ask you. Very good, there you go, Anna. Yes, it is lens formula. Amazing, amazing. Array, objective lens, it's a convex lens. Can't we use the basic formula of our lens? 1 by V naught, 1 by U naught is equal to 1 by focal length of objective. Can't we? Can't we find out 1 by V naught from here? बोल दे हाँ सर बिल्कुल कर सकता है, क्यों नहीं कर सकता है? तो substitute. What is the focal length of objective? 1.2 plus 1 by, what is the distance of the object from the objective lens? U naught minus 1.25 minus 1.25, right? So how much is this going to be? Minus 1.25 plus 1.2, if you cross multiply, that is 0.05 with negative. This becomes 1.2 into 1.25. This is 1 by V naught. Ulta kar le. V naught 1.25 and 5 will become 125 divided by 5. 1.2 with negative. 5 in 12 how many times? 5. 2. 2. 5. So this becomes 25, right? So 25 into 12, 25 into 10 is 250, into 12 is 300.2. This is 30 with negative. Simple. Simple ka dimple. हमको क्या मिल गया? The distance of the image from the objective lens V naught मिल गया. अरे V naught मिल गया तो why you have to wait? Substitute and get your answer. जल्दी. हाँ. V naught minus 30. U naught minus 1.25. ठीक है. D, least distance of distinction. We know that it has a constant value of 25 centimeter. Then focal length of eyepiece. Focal length of eyepiece कितना था? Okay, 3. Minus minus will cancel, right? And 30 by 3, 10 हो गया. Then 25, 125, 5 times, right? So this becomes 0.05. Then this can be written as how much? Answer option B. Simple ka dimple? Anyone gave me the answer? Hare Mridula 200. Very good. Miara, Sophia, Shivaji. Very good Anna. Very good. सबने दे दिया. तो समझ में आ गया how to how to apply the values in the formula and what kind of questions you can expect from this part of microscope. Is everything clear? Understood? Yes. Shreya, yes. Hi, hello. Okay, very good. Hi. ठीक है. Now, this is more than enough from the part of microscope. Now we are going for telescope. Tell me, why we use a telescope? Everyone knows, right? Those who look into the picture itself will tell me, mainly we use a telescope for looking into astronomical objects. Matlab, looking into stars, other planets, and what is very far away from us. That is astronomical telescope. We also have a terrestrial telescope. Matlab, if you are at one point on the earth, if you want to look at some objects at very far away from the object, which means very far away from your place on the earth itself, you also need telescope in that case, right? That telescope which we use, we call it by the name of terrestrial telescope, right? To observe a point B from a point A which is very far away from each other, right? There we use terrestrial telescope. Let's understand about both of them, but according to our NCERT, we only have astronomical telescope to be learned. This I'll give you a brief idea on the working of terrestrial. देख ले. Here also, in the case of telescope, just like how microscope was, there will be two lenses. Which are the two lenses? Objective lens and the eyepiece. But a small difference you can see here. What is the small difference that you can observe? Who can tell me? I'll draw the figure. Looking into the figure, let me see who can tell me this. This is our objective and this is our eyepiece. Okay, let's say this is our focal length of objective. This is a focal length of the objective. First, we are going to find out about the working of a astronomical telescope. Astronomical telescope. In astronomical telescope, we'll be having the final image formed. I is formed at infinity. Yesterday itself, I have explained why we have the image formation at infinity, because whenever the image formed is very far away from us, it will be a relaxing state for the eyes to look at. Whenever you have any image very close to us, dekhle, isn't it a bit hard to look at? Yes, right? Whenever our image is very far away, such as in the case of infinity, it will be very easy for us to look for the eye without any strain. Okay, so tell me, what is the difference that you can find here when I drawn the picture? Once I have drawn the picture for the telescope, what is the main difference you can see? कोई भी, you haven't found any difference. कोई भी difference देख भी नहीं सकता आप लोगों को. No difference at all. Very good. Aperture of the lens has changed. If you look into the objective here, the objective is having a larger aperture or a larger size compared to the eyepiece. Aperture means that length between its tips, right? So who's having? Objective. Can you make a wild guess why here the objective has to be larger? Because the object here in this case is coming from infinity, है ना? The light rays are coming from infinity, or we use telescope to look at the object which is very far away. In order to have a better clarity of the picture, more amount of light rays should be coming, isn't it? If more is the number of light rays, more will be the intensity of the final image formed. If more is the intensity of the final image formed, we can have a better clarity of the final image. We can look at the image in a better fashion. So the reason for having large aperture is it will let more amount of light rays to pass through it. समझ में आ गया? Okay, but in the case of microscope, the object is kept very close to it. So there is no need of having a larger aperture. Small aperture itself is enough to let the maximum amount of light rays to pass through it, because object is very close to the objective lens in the case of microscope, unlike the case of telescope. समझ में आ गया? ठीक है. Now look into the image formation. So here we have the focal length of the objective lens. On the other side also focal length of the objective lens. What happens? A light ray which is passing through optic sender will be passing without any deviation, ऐसे. Okay. And this will be converging. You know that where the image will be formed. An object at infinity for a convex lens, where the image is formed at the focal length of the objective, isn't it? At the focus you can have the image. So I'm marking this as the distance v of objective. कोई गड़बड़ है? कुछ भी नहीं है ना? Where should we be having the final image? At infinity. And you know that the image of the objective will be acting as what? This will be acting as the object for the eyepiece. Why? Because the light rays from the image of the objective has to pass through the eyepiece lens for the final image formation. As the light rays are coming from the image of the objective, this will be considered as what? The object for the eyepiece. Where should be the object of the eyepiece should be, so that the final image is formed at infinity? Where should the object be with respect to a lens for the image formation at infinity? Very simple question. Very simple question. Chotu motu question. Bol de. It should be at a distance of its focal length, which means this particular image of the objective lens should be formed at the focal length of the eyepiece also, so that the final image formed will be okay. You can have the final light rays parallel, which means the final image is formed where? At infinity. समझ में आ गया? सबको समझ में आ गया ये? Very simple. Where did I keep my phone? हाँ, I kept it here. सबको समझ में आ गया? Yes, I can see the answer from Anna at focus. Very good. Others? बच्चा लोग? Any doubts? Is it clear? If it is clear, we can go for the length of the telescope, okay, and also the case for magnification. Okay, so I'm going to assume that everybody have understood, because I'm not able to see any doubts in the chat box. ठीक है? So yes, let us go for magnification. Okay, you know that whenever the final image is formed at infinity, it is not possible to find out the magnification by using the usual formulas. So what we did in those cases for finding magnification? For finding out magnification in those cases, what it did was, instead of taking height of the image by height of the object, we found out the angle subtended by the final image to the angle subtended by the object, instead of having height of the image by height of the object, as the final image is formed at infinity. For finding out magnification, we took the angle subtended by the image to angle subtended by the object. If you want me to write, beta is angle by image by angle by object. The reason why we take angle, because if the height is more, the angle will also be more, which means these are directly proportional. Okay, so instead of finding this, we are finding out angle, because the final image is formed at infinity, and it is impossible to find the magnification by using the direct formula of height of the image by height of the object. So let us start marking. Where is the final image formed? This, right? So what is the angle it makes? ये है ना? Isn't this the angle it makes? है या नहीं? Where the final image formed, right? So how can I write beta? Opposite. Let's call this as h, divided by adjacent. What is this? Focal length, whole divided by alpha. What is alpha? From here the light rays are coming from the object, so the angle it makes is alpha, right? This is alpha, this is alpha, opposite. Consider this triangle, है ना? Alpha is opposite, the same h, by adjacent. What is this? Focal length of the objective. So ये हो गया focal length of the objective by focal length of the eyepiece after this h is cancelled. इतना आसानी से we got the equation for magnification. For what? Magnification for, yes, for a telescope where the final image is formed at infinity. And what do we call this particular telescope? Astronomical telescope. Why? Because we use this setup of telescope for viewing astronomical objects in the space objects. बस कोई डाउट है तो बता. कोई डाउट नहीं. पक्का पक्का. Okay. Now let me ask you, what will be the length of this telescope? L. Who can update me in the chat box? The length of the telescope, which is the distance between the objective and eyepiece. हाँ, what is your doubt, Ritu? पूछ ले मुझे. Yellam perfect time यारा. Understood. Seems like I do have only one student who is so much serious about studies. I can see the answers from Anna all the time. When I ask you what is the length, she has given the answer perfectly. जल्दी से बोल दे. Aruna is like, we are at the end of the chapter of ray optics and now she is asking कौन सा chapter चल रहा है. बढ़िया. Okay. Just look into the figure for finding out the length of the telescope, means the distance between the objective and the eyepiece. Till here, focal length of the objective. From here to here, focal length of the eyepiece. Any doubt? So net length is equal to focal length of the objective plus focal length of the eyepiece. Bas. Understood? Bas. This is only. Okay, this is astronomical telescope and it is only till here we have to learn according to NCERT. But I have seen some questions popping up for JEE and NEET from the terrestrial telescope. Okay, we are not going to do the or draw the diagram for that because it is not there in our NCERT, so it is not so much necessary. But I'll tell you how the figure will be looking like for a terrestrial telescope. In the case of a terrestrial telescope, the only difference is instead of having the final image at infinity, the final image will be formed at least distance of distinct vision at D. That itself, okay, that case where the final image is formed at least distance of distinct vision, which means that capital D itself is a working of what kind of a telescope? Of an terrestrial telescope. This is for astronomical and what I explained is for terrestrial. And what I have seen is the equation for magnification. Equation for magnification of a terrestrial telescope. TT, table tennis, बिल्कुल नहीं. Terrestrial telescope. Formula is F0 by Fe 1 plus. We have learned till now 1 plus D by Fe. So here in this case it will be Fe divided by D. Not there for your board. Okay. Not for your board exam, but you can see it for JEE examination and NEET examination. Magnification for a terrestrial telescope where the final image is formed at least distance of distant vision. Everyone can try drawing the figure. Magnification formula, please do by heart. F0 by Fe 1 plus Fe by D. Bas. Okay, only till here. Itna hi hai. Only this much to learn from the chapter of ray optics. We are done with the entire chapter. और कुछ नहीं, और कुछ भी नहीं, कुछ भी नहीं, और कुछ भी नहीं. Shall we start doing the questions? Questions करने ready? अरे ऋतु, आपका बर्थडे है. ठीक है everyone. Let us take 20 seconds and wish her a birthday everyone. Happy birthday to you. Happy birthday to you. Happy birthday dear Ritu. Happy birthday to you. Okay. So may God bless you to have so many amazing years ahead. Okay, enjoy your life and please do learn also. Okay, exams are coming. Okay, so we all are expecting cake from you, Ritu. Okay, to our houses. I hope you are going to send us. ठीक है. So coming back. ठीक है. Birthday party फिर. Let us complete this chapter. Everyone coming back. हाँ. Wish कर दिया ना सबने ऋतु को. Now coming back. Let us do this problem. Astronomical telescope, which means our normal telescope. The telescope which we use to look at the astronomical objects. ठीक है. Has an angular magnification of magnitude 5. Magnification is given 5. For distant objects, the separation between the object in the eyepiece, matlab, what is it? The length is 36. Final image is formed at infinity. Bilkul, because for astronomical, you know that final image is formed at infinity. ठीक है. Determine the focal length of the objective and eyepiece. ठीक है. Determine the focal length of the objective and eyepiece. कर सकता है? From magnification and length, how is it possible? Those who do remember the formula can simply get the answer. Magnification का formula f0 by fe. Length का formula f0 plus fe. Two unknowns, two equations. Who can't solve this? A 5th grader can simply solve this, है ना? Then why can't you 12th standard students? Tell me. 5 equal to f0 by fe. From here you can make an equation for f0. f0 is equal to 5 times fe. Bus. Substitute here. f0 is 5 times fe plus fe is equal to 36. 6 fe is equal to 36 and fe हो गया 36 by 6. How much? 6 centimeter. Exactly. If you knew these formulas, we could have got the answer ऐसे. Even the calculation itself is simple. Array focal length is, of eyepiece is 6. So what is focal length of the objective? 5 times focal length of eyepiece. 5 times 6, 30. ठीक है. Perfect 0 भी हो गया. Look how simple it is. Nothing is there much to do there. Understood the concept? सबको? Without any issues. अच्छे से. बोल दो, if you have any doubts, do let me know. Okay, next question. और कोई question तो नहीं है. Shall we do this question? Option B. Was it option B? I forgot which option it was. f0 is 30, fe is 6. Yes, it is option B. Option B. बढ़िया बढ़िया. भूमिका, प्रियू, म्यारा, जतन. सर नींद आ रही है. Okay, 10 more minutes last. बस हो गया. Try to control your sleep for next 10 more minutes. बस. Got it. अगले क्वेश्चन कर ले. A simple telescope, okay, consisting of an objective of focal length 60 and a single eye lens of focal length 5 is focused at a distant object in such a way that the parallel rays come out from the eye lens. Parallel rays come out from the eye lens means, can you tell me where the final image is formed? Where the final rays are parallel. Where? Image at infinity. Look how things are hidden inside the question. So this simple point itself should be there so that you will be getting the answer. है ना? Because without this particular thing, you cannot finalize what is the equation for magnification, whether it is f0 by fe or f0 by fe into 1 plus fe by d. Right? Now it is being confirmed. If the object subtends an angle of 2 degrees, what is it? Alpha. The angle subtended by the object is actually called as what? Alpha. The angular width of the image. Beta. The angle made by the image is the question. When alpha and beta comes, you know that the only equation is magnification is beta by alpha. But nothing is directly given related to magnification. कोई बात नहीं, because you know one more equation to find out magnification formula, f naught by fe. Now हो गया, the only unknown is beta, कर सकता है ना, और क्या, this is f naught by fe into alpha equal to, what is f naught? Focal length of objective 60, focal length of eyepiece 5 into alpha 2. So 5, 10, 12. बीटा का वैल्यू हमको मिल गया 24. अरे ये भी ऑप्शन बी है. Seems like we should always be going for the option B, because option B is coming right answer all the time. ठीक है, अंडरस्टूड टिल हियर? अच्छे से समझ में आ गया, कोई गड़बड़ नहीं? वेरी गुड मियारा, इट इज यस 24, बिल्कुल बढ़िया. अरुणा ऑप्शन डी नहीं, इट्स नॉट ऑप्शन डी, प्लीज चेक, इट इज ऑप्शन बी 24. हाँ सुदीप, I drank. Yes, it is 24. Right, Ritu understood. Miara, Sudeep, Aruna, समझ में आ गया? So Aruna, please check where you have gone wrong. Okay, please check the answer and the solutions and check where you have gone wrong. Option B is only coming, right? I did. I drank water. Now, at the very final ending of this particular chapter, you can see regarding reflecting telescope. Till now, the telescope which we were using was with the lens. Inside the lens, what we have? Refraction. So this telescope, we call it by the name of refracting lens, okay, or refracting telescope. But there is a small demerit for using this refracting telescope, because I told you, in the case of refracting telescope, the lens, the objective lens is very much huge and large, right? If it has to be very large, right, there should be some specific mount on which this can be fixed. You know that we cannot fix on either side of the lens because it will cover the lens. So there should be a very huge and an very good mount should be there, so that this lens can be fitted. But for making such kind of mount and everything, this is going to be very much expensive, and this is a bit risky game, right? Which means you have to hold at the end of this particular lens, which is so much bigger in size, and you have to keep it somewhere, right? So this kind of telescope, which is a refracting telescope, it's very much costly and it is very much a risk to make. So in nowadays world, in the modern world, we won't be using what? We won't be using these kind of refracting lenses. What we will be using is reflecting lenses. Reflecting matlab, हाँ बिल्कुल, we are using mirrors. Which mirror? Which mirror? Yes, we will be using concave mirrors. So let's see how the image formation happens in reflecting telescopes. Light rays will be coming from infinity, है ना? And it will be reflecting and converging at its focus. And if someone can sit here, right, if a person can sit here and receive those incoming rays, what will it be receiving? Obviously, what will be receiving? Yes, it will be receiving the final image in its eyes or in that person's eyes, right? And these kind of reflecting telescope, we call it as Mount Palomar telescope. What is the name? Mount Palomar telescope. It is given as a small paragraph in your NCERT at the last, so I'm just explaining to you. It is a simple concave lens. Light rays comes, will be reflected and will be converging at its focus. We will make a person to sit here and can observe that image. But here the intensity of the image formed will be very less. Why? Because the person is sitting here and he will be blocking many of the light rays coming from the object. So instead of Mount Palomar telescope, which is a reflecting telescope, we will be having Cassegrain telescope. CSSEGRAIN telescope. Why we are replacing this Mount Palomar? So that there will be minimum blockage of the light rays. And how it will be constructed? It will be having the same concave lens, same concave mirror. Light rays will be coming. Okay, light rays will be coming. It will be reflected. Essay. But we won't make the person to sit here. Instead, we will be keeping another convex mirror. And what will this convex mirror do? It will be reflecting back the light rays as such. And now the person will be standing here where to receive the light rays passing through the small hole created where? Created at that concave mirror part. समझ में आ गया? Okay, so this is a Cassegrain telescope and this is Mount Palomar telescope. A small statement given, a small paragraph which is given at the end of this particular chapter. And bus, here we are at the end of this chapter. End. Okay, and on Monday we are having the Menti quiz from this particular chapter. Okay, so don't miss this. Menti quiz is there on Monday. Don't miss the Menti quiz on Monday for the chapter of ray optics. And one more thing, let me tell you, on this Sunday, 3rd of October at 3 p.m. You know that we are very fastly approaching towards our term 1 examination. So what is the time for? Yes, it is the revision time. Yes or no? Revision time. So as part of this revision plan, the complete chapter revision, the complete chapter revision of AC will be done on the Sunday at 3 p.m. in the Unacademy class 11th and 12th chapter by me. Not just the chapter revision, you will also be having the Menti quiz on this day. So don't miss your chance. Don't miss this opportunity. Amazing class. Yash, thank you so much. So सबको समझ में आ गए? Without any issue, without any गड़बड़, अच्छे से, बहुत अच्छे से. So how many of you should or should I be expecting on this class on this Sunday? How many of you should I be expecting? Thank you so much, Ritu. Sure, Hiba, bilkul, I'll take care of my health. Thank you so much for the concern and care from everyone. Bol de, how many of you will be there jaldi so that I can keep expecting these names in the chat box on this day? Thank you, Miara. Sure, Ritu. हाँ, AC chapter complete. Pura ka pura. Anna will be there, very good. Sanjana will be there, है ना? Aruna, I'm gonna assume you're gonna be there. Sir, आपका कल no from because I have already told you on Wednesday we won't be having the class in YouTube. Classes will be there on the Unacademy platform. That's the reason. Okay, so Sudeep, Real Addict, Priyu, Priya, Ajmeri, Ankit, Hacker, Sanjana. So I think most of you will be there, right? So ठीक है. So I think this is the time for saying bye bye. And those who haven't liked the session, those who haven't shown some love towards Ameer sir, jaldi se jaldi hit on that like button and do let me know that you are understanding all the concept. You are appreciating all the efforts taken by me and all the teachers of Unacademy class 11th and 12th channel. right? And फटाफट like कर लिए सब. And let me tell you, whoever is going to prepare for the JEE or NEET, I think it will be a best option for you to make a, let's say, a small revision, right? A crash course. So a crash course for actually term 1 for first year is happening. 12th standard students also can join, so that you can revise the part 1 book of your physics along with biology, chemistry and mathematics, right? So I'll be there, Anurag sir will be there, Pranjay Goyal sir for biology, Vivek sir for chemistry and Nikki ma'am for mathematics will be there. We all are expecting every one of you to join us soon, right? And it starts on 11th of October. And if you are going to make the subscription, the code that you have to use is AMB10. So this happens in an Academy platform, in the Unacademy app. If you wish to join for this crash course, use this code of AMB10 and get enrolled with a 10% of discount. Okay. So yes, thank you so much everyone for being here and making the class so awesome by giving so much of energy to the classroom. I am so much thankful to you. ठीक है? So आपका अमीर भाई आना जा रहा है. Okay, yes, we can see on Sunday 3 PM for AC. So अलविदा कहने का टाइम आ गया. ठीक है? Yes, it is AMB10. So thank you so much. Those who haven't liked the session, jaldi se like kar le, and do let me know that you have enjoyed the session. And those who haven't subscribed can subscribe to the channel so that you'll get all the notifications. So me, on behalf of Unacademy, is going to say bye to everyone. We'll be meeting on Sunday, 12th standard students, and for 11th, we are having loss of motion complete revision at 8 PM today, so you can come and join. So thank you so much. Bye everyone, and let's crack it.